Hello, everyone. We're going to start in just a few minutes. So that's exactly the time to grab a cup of coffee, and we'll come here in a few minutes. All right, so let's get started. So, hello everyone. Welcome to the 11th event of our special online meetup series hosted by Web3 Dev Underground. Before we dive in, let me briefly introduce our community. So we're a community of Web3 developers and builders funded on open source values by Shuli Rejwan and Woya Shirov. Since we started 3 years ago, we've consistently hosted in-person events, bringing together some of the brightest and technical minds in the space. Recently, we've expanded to online meetups, and we're committed to delivering top-tier technical content to the global Web3 community. We're thrilled to have you all with us today. So to stay in the loop for future events and updates, please make sure to join us on all platforms: X, Luma, Meetup, YouTube, Telegram, and more, all available on our link to your website at web3devs.org. A special thanks to our community sponsor, Masterkey VC, an early-stage venture capital firm focused on infrastructure and deep tech across the Web3 ecosystem. With a team of 16 world-class cryptographers and several technical experts led by managing partner Sholi Rejwan, Masterkey operates across all major global crypto hubs. And now, without further ado, I'm honored to pass on the mic to Arik Galansky, VP Technology at Fireblocks. Arik, the mic is yours.
Thank you, Eden. Can you all see the presentation? I think it's still the starting soon is showing up. Okay, I hope you can see the presentation now. Okay, great. Hi, everybody. Great. Okay. Hi, everybody. As Eden mentioned, I'm Arik. I lead the technology research at Fireblocks. And I'm here to talk to you about, I know there have been a few conversations about MPC, and there have been a few conversations in the past about account abstraction. And I think this is an interesting topic to talk about, is the combination of the two, specifically with, I can call it the new EIP, even though it's not very new, introduced in Pectra, EIP 7702. Now, the angle that I'm looking at this, I'm not going to just explain what EIP 7702 is. I will briefly, but there's a lot of material to really get into the EIP itself. I think what's interesting is to talk about it from the angle of actual real-world usage, how we think about the technology as it's being introduced in Ethereum or any other blockchain. How do we connect it with other technologies? So it's really an opinionated, but also it has a very specific context of us looking at this. And maybe that's a good time to say what us means. Fireblocks. I'm assuming some people here are familiar with Fireblocks, but just to kind of set the ground. So we're a provider of infrastructure for companies that want to use the blockchain for different use cases. A lot of our clients are in the custody space, payments, tokenization, all of the hot buzzwords that are happening today, but also the ones that were happening 2 years ago, 3 years ago, and 5 years ago. More than 300 million wallets on Fireblocks. We have more than 2,000 institutional customers, which basically to say we're not servicing private people directly, but as you can see from 300 million wallets, we do serve a lot of probably a lot of you indirectly through clients that use Fireblocks as they service you, either because they're a bank with some cryptocurrency features offering, maybe because they're a payment company moving money around that you paid on crypto rails, and again a lot of other things. Fireblocks has secured more than $10 trillion so far, and so basically we're seeing very meaningful volume on the Fireblocks system. And as you understand, security is a top concern for us, but also usability and everything else that involves integrations. And we are a multi-blockchain company, right? It's not just Ethereum. We support more than 50 blockchains, I think. So it's very, very important for us to see. But obviously, the EVM ecosystem and Ethereum specifically is a very important part of our business and our offering, especially with everything that's happening around stablecoins nowadays. Great. Okay, so let's dive into this. So obviously, as I mentioned, I want to come through a specific angle into this conversation of account abstraction. So let's start with talking about the account model on Ethereum. So the account model in Ethereum is pretty simple. It's pretty simple, but it's also a bit complex, right? Because there's basically two kinds of accounts on Ethereum. You have the EOA accounts, which is what we call, like, that's the regular account. That's the one you have on MetaMask. It's actually called externally owned account, but this is the account, with the private key that you need to, like, in some situations, have a passphrase or something like that to remember. And that's what we think about as accounts on blockchains. And there's the smart contract accounts. Now, a lot of the smart contract accounts until recently were mostly for applications. And I think this was the design of Ethereum, thinking about how to design this. So EOAs was for people, and smart contracts was for applications, like Uniswap is a smart contract account. And those accounts have different characteristics, different capabilities. Only an EOA can send a transaction on Ethereum. A smart contract cannot initiate a transaction. But only a smart contract can run code. An EOA cannot run code. Well, until recently, but we'll talk about this for both of these. So this is like the basic model that we're starting from when Ethereum was built. And it was the dominant way of looking at this. Now, a lot of people don't like EOAs. There's been a lot of conversation about EOAs being bad. And obviously, some of this is more like people trying to push their products. But I think there's a few specific points that people have against EOAs. And those are like the arguments that people have against EOAs. Single point of failure in private keys, no backup, no recovery, no social recovery, which is something that a lot of people in the Ethereum ecosystem like. There's no built-in security into EOAs. It's just the private key. Now you need to handle everything else. If you want to send a transaction, the only way to send a transaction is EOAs, but they must have Ethereum already. So you somehow need to get Ethereum before you start the process of sending a transaction. There is no batching. There is no permission management. There is no session keys. There are no session keys. Generally speaking, anything that requires code execution on chains can't happen on the EOA itself. So those are kind of a lot of the points that people were driving as they say we need something better than an EOA. And the direction to solve EOAs that was kind of like the main direction in the Ethereum ecosystem is ERC 4337. And what ERC 4337 does, and this is like a very oversimplification, is it allows smart contracts to send transactions. Okay. Now, it doesn't actually allow them to send transaction because it's not transactions. And that's not the only thing it does. But as a simplified version of looking at it, you can now send a transaction in a smart contract, which basically gives you everything, right? So it looks in this kind of context, it looks very good. And so some people started to think, hey, if a smart contract can send transactions now, why do we even need an EOA, right? Like, why is it necessary? Maybe we should throw the EOA out. Maybe we just need smart contracts, smart contract wallets in the ecosystem. Now, the thing is that people actually like their EOAs. And we see this, right? We'll see this in the numbers. And maybe like that's, we'll get to this in a few. But there's a few different things people love about EOAs. And so I think it's worth mentioning them because a lot of these things were not part of the conversation because the conversation was very one-directional. Move to account abstraction, move to smart contract wallets. So here's the things that prevented people from moving. First of all, the price. EOA transactions are just cheaper, okay? Now, a transaction via an EOA is cheaper, and the deployment of an EOA is literally zero. So you create a random number and you have an EOA. So like there's no cost on chain for creating an EOA. Now, it might not matter when you're creating one, but when you're creating a million, suddenly it matters. So that's number one, price. EOAs are better on price. Number two, security. Now, I know this is counterintuitive because I just mentioned EOA do not have security, but the ecosystem around EOAs actually built a lot of security features. As I mentioned, Fireblocks, for example, right? Like $10 trillion running on our system. Obviously, there are some security tools in this, right? And we're not the only one. There's actually a lot of security tools that are built on EOAs. And if you change to a new paradigm, you lose some of them. Some of them will support like smart contract wallets, but some don't. So the entire ecosystem of security that is really battle tested in all of the years Ethereum was working on most of the Ethereum accounts, almost all of them, is tied to EOAs, which basically is like the second point, like the next point, which is maturity. Everything in the account abstraction ecosystem was new because it was new, right? So it was new bundlers and new user ops, which is like a new kind of transaction, and new paymaster mechanisms and the new entry contract. So everything was kind of not battle tested, still changing, still work in progress. Obviously, some of those things by now are mature, but not as mature as the EOA parts. And a lot of them are actually still evolving. It's not clear yet who's like the best bundler and why, and what does it even mean to be a good bundler. And the way the ERC 4337 was built is actually to go around the existing ecosystem. That's why it's in ERC, not in EIP, and create a new ecosystem. And so that's what happened, but it means that like this ecosystem is not as mature. And another thing that not a lot of people talk about is not everything is supported in smart contracts wallets, but actually everything is supported in EOAs. 100% of the apps you can use on Ethereum support EOAs. Another thing is locked value. So one of the problems of moving to a smart contract wallet is you leave a lot of things behind. Maybe you have value that is possible to transfer, but is expensive. For example, a lot of tokens. So transferring all of them would just take a lot of transactions. Perhaps you have open positions on some DeFi protocols. Now, do you need to move them to the new wallet? It might mean even like tax implications, right? So it can be complex. And I'm not even talking about SBT, soulbound tokens, which literally cannot move from an EOA account. And the last one is signing messages. So signing messages off-chain is not an actual feature of the blockchain, but there's a lot of apps and a lot of other systems that use signatures. Now, there is a solution with ERC 1271, but not everybody supports that solution. So the reason I wanted to spend a bit of time on this is to make the Stillman argument for EOAs, because I don't think it's made enough time, even though EOAs do have disadvantages. And like you can see some of them here. As I mentioned earlier, this is obviously a partial list. But EOAs have some advantages, like it's cheaper or it can send transaction more natively. But also it has disadvantages. It can't do batching, and you don't have built-in multi-sigs, which obviously you have in other systems. And in smart contract multisigs. So it's actually quite a complex comparison when you compare an EOA to a smart contract, even when you add ERC 4337 on top of it. Now, I'm going to continue running this comparison by these actual parameters. And again, I want to acknowledge that there are additional parameters. Like I'm not talking, for example, here about post-quantum readiness or something like that, which is definitely relevant in the long-term future of this ecosystem, but it does focus on what it looks like to run a wallet-oriented application today, right? I think this captures a lot of the core things, most important things in that context. And we're not looking into like the general blockchain or Ethereum ecosystem, but specifically to you as a user. Okay, now this comparison is complex enough that actually, and just make sure you notice, this is from a year ago, okay? I didn't check the numbers now because what I was interested here is in the number of account abstraction wallets when 7702 was introduced and when it was discussed. So it's pretty clear the adoption was not there. And this is Ethereum mainnet. There's L2s, there's a lot of other things. So a lot of the people were actually choosing to stay on EOAs. And I think that's important, right? Because that shows something was missing. The Ethereum ecosystem actually came up with another idea, and it's not exactly a new idea. It was circling around the Ethereum ecosystem, but it became stronger around a year and a half ago. And that idea was, what if we make EOAs better? So instead of just trying to replace EOAs, which obviously didn't work so far, what if we decided that it's okay? We understand EOAs are here for some amount of time at least. Let's make them better because it will improve the entire ecosystem. It will improve the offering that Ethereum can give to its users without requiring them to do something they don't necessarily want to do. And that idea started to get some traction. Now, before I move to show what happened with it, I need to touch a bit on the other side of the equation, because we said this is like an EAP 7702 meets MPC lecture, so we need to say a few words about MPC. So what is MPC? I hope by now everybody knows, because you've seen hopefully 3 different lectures about MPC just in this meetup series. But as a primer, the idea of MPC is 2 things. Number 1, you decentralize the key generation, okay? You don't have to. It's sort of like a separate thing, the DKG, decentralized key generation process. But MPC doesn't make a lot of sense in this context if you don't decentralize the key generation. So what it means that you decentralize the key generation is that there is no single key at any point of time, even during the creation. So there is an imaginary key that exists somewhere in the world, but nobody knows it and nobody has a way to get it. So it's sort of like the key that exists but doesn't exist. Now, the public key obviously exists, but the private key is in this weird state that's a bit weird for us to think about. So we have decentralized key generation. The second part we have is basically the signing process. This is what we think about when we say MPC, which is a signing process that does not require us to reconnect the key for signing. So the regular mental model we have, if I tell you 3 people hold part of the key and we need to sign, what you will usually do is you will assume they combine the key and then they sign, right? Because that's easy for us to imagine. You have parts, you combine them, you sign. But in MPC, this is literally the thing. In MPC, you don't combine. You talk between the parties and they collaborate. Each one of them does part of the signature and a legitimate signature is being created. And again, there's an entire mathematic field of threshold signature schemes within MPC that talks about how you do this in the context of elliptic curves and other relevant fields. And there's a lot of capabilities here. You can do different thresholds, like 1 out of 2, 3 out of 5, 7 out of 300. You can do multiple thresholds on the same key for different situations. So there's a lot of things you can do. So this is very, very simple MPC. If you want to get deeper into MPC, you definitely need to look into some additional material, because otherwise it will take all of our time. Okay, so this is basically MPC. Now, a very common combination that I think Fireblocks was one of the early adopters of that combination and made it very popular is MPC plus TEE. Now, the idea is MPC gives you some guarantees and trusted execution environment gives you additional guarantees. And you combine them into something that is meaningfully more secure than each one of them by itself. Because even if you run MPC, one of the problems is that each party will be able to see its own part of the key. And so if somebody hacks into your computer, now they can get your part of the key. But if you put the key in a trusted execution environment, there's a lot of different trusted execution environments, paradigms out there and products out there. If you put the key in that, then now if somebody gets into the device, they cannot see it, because it is actually secured on the hardware level, so that even if you hack the operating system, you're not supposed to be able to get to the trusted execution environment. And if the trusted execution environment is even more complex, you can actually run your code inside it, right? And we're familiar with that from a lot of products that are coming out right now. I think MPC wallets were possibly one of the, if not the first use case for trust execution environments in the blockchain space. But that combination became very popular, and now people use TEs for a lot of things. Now, what TE gives you is verifiable execution, first of all. So you know what was executed, but you don't have access to the execution itself. So you cannot change anything. You cannot look at anything. It actually gives you a lot of security properties for the secret material. For the secret material itself, like the share of the key, but also for your code, right? Like nobody can intervene with the code that you're running. Great. Okay. So again, MPC and TE, this is a combination. So in this combination, what do we get? First of all, no single point of failure. Before that, we were talking, there's one single private key. Now, no, there's shares of a key, right? So it's not a single point of failure. We have multiple parties that you need to compromise in order to get the key. And you get a lot of security in depth because you have like the cryptographic security and you have the hardware security of the TE. And if one of those parties has a lot of other layers like Fireblocks, like a service provider, they can start adding more layers. For example, access control and policies and things like that. You also can get backup, right? Because now basically you have a lot of different options into how you want to operate your wallet. For example, you can have multiple different splits of the key and one of them is backed up. So you can create a lot of things with MPC. With basically thresholdizing your key. And the last thing you get is partial privacy. Because one of the interesting things about MPC is that when you have an MPC wallet and you sign a transaction on chain, nobody knows it's an MPC wallet, okay? And this is really interesting. If you look at the blockchain, it looks like, oh, there's just one guy holding a private key, but behind the scenes, you might have like a very robust system with multiple signers, hardware security, automated policies, like a lot of the things that you want in a real production system, especially ones that protects a lot of money. But to the outside world, they don't even know. So sometimes it's a bit funny when people say, oh, look at this, there's just one signer here, but there might actually be the entire system behind it. Okay. So if we take the EOA and we add MPC and TE to it, then we actually get this better system than we had before, right? Because we have all of the EOA advantages. We didn't take anything from the EOA. Remember, on-chain, it's the same thing. But we added a multisig. Right now, there's multiple parts to the key. And the multisig is actually multi-chain supporting. It can be actually the same multisig if you want across different chains, whether if it's multiple EVM chains or if it even goes to like Bitcoin or something else. And you can get backup and recovery because we talked, you get a lot of backup options, and you get partial privacy because nobody knows what you have behind the scene. You can have like very complex security setup. So it really gets better with MPC. So that's already a good start, right? And this is just looking at this. This is probably why MPC wallets became so prominent on institutional blockchain use cases, because a lot of the things MPC gives is actually very valuable, and it is multi-chain supporting. So you don't have to create a separate process for each blockchain. You can actually have one process across all of the blockchains you support and have the same security to all of them. But now I want to reintroduce 7702 into this. And to do that, first of all, I need to explain what 7702 is. And I will not go into all of the details. Again, there's a lot of material about 7702 as a separate technology, as its own thing. A few things I want to mention. What does 7702 do? First of all, 7702 is an EIP. It's not an ERC. Okay, so it's actually built into the blockchain. There's a new thing in the blockchain that was added in Pectra. That new thing is that an EOA that did not have code execution in the past now can actually have code execution. And the way it will have code execution is that it will sign a delegation message or authorization message to some contract on chain. So you can think about it as a pointer. There's a pointer on the EOA, new thing, that allows you to delegate a contract that when somebody tries to execute you as if you were a smart contract, the code of the EOA will be taken from that smart contract. Okay, now it is important to say those smart contracts actually have to be 7702 compatible, because if they're not, this is not an official thing being 7702 compatible. But if you're not, it adds in like different security risks, which I will not go into. So it's really important. You don't just delegate to a contract. Like, for example, a simple mistake you can do is delegate to an old safe contract, right? Because you think it's a smart contract wallet, but the old safe contracts are not 7702 compatible. So that would be a mistake because somebody will steal your money. Now, so you basically do this. You do this one-time delegation, and the result is you now delegate it to this contract. And this is persistent, okay? So once you activated the delegation, it does not end at the end of your transaction. It remains with you until you will do something else, until you decide to redelegate to a different contract or cancel your delegation. And both of those things are possible. You can cancel delegations. You can delegate to different contracts after you've delegated to a contract. Again, there's some security considerations there. It's not like you don't just move contracts around however you want because somebody might be targeting this kind of behavior. You do need to be smart about this, but it is possible. So as I mentioned, it's persistent, it's on-chain, and another important thing is it's gasless. And that's important because it means you can delegate from step one. You don't have to first get Ethereum, then delegate. We'll be talking about some things that the delegation gives you, like gasless operation. It would be kind of silly if you wanted to get gasless operations, but you had to get ETH to activate it. So actually, this is a good thing about 7702. It is the delegation itself is gasless as long as you can find a relayer that will pay for your costs. And that's a separate topic. And another important thing is that while you delegate, so the thing is, you don't transform to be a smart contract wallet. You are actually still an EOA. And you can send transactions as an EOA. You lose nothing from your EOA capabilities. The only thing is you gain smart contract capabilities. It's only addition. It's only an upgrade. It's not a change, right? It's literally just adding configuration. It's just adding options, not removing anything. And again, this is like very important. We'll talk about this more. Okay, so once we've added the AP 7702, and once we added ERC 4337 before, what we see is we have a bit of an equilibrium here. So now smart contracts can initiate transactions via ERC 4337, paymasters, and the bundlers, and the entire process there. And EOAs can run code via 7702 delegations if they activated it. So now there's a lot more options for each one of the kinds of accounts. But more important than the fact that the accounts are each upgraded is that they actually have a similarity. So any account that activated 7702 or can use 4337 can basically both initiate operation and run smart contract code. Now, all of the accounts on Ethereum can potentially have similar capabilities. And that's very important because this is actually one of the things that are driving adoption. The fact that it's no longer a competition between these guys and these guys, we can work as one ecosystem to create better processes. And there is a lot of work there. But this is really, really important in what 7702 did for the ecosystem. But the other thing it did is it improved EOAs once more. And when we add this, we actually see that with this addition, we do have even better EOAs. And again, not selling anything, right? There's other parameters here, but these are the parameters we care about in the context of a wallet the most right now. So I think this is a valuable kind of comparison in this. Okay, great. So you can see this is really pushing us forward, right? 7702 really gives better capabilities to EAOAs. And the way that it does it is because it basically takes the best of three worlds. You have EOA, which is compatible to everything. We mentioned 100% of the dApps support EOAs. All of the Ethereum ecosystem around the Ethereum insecurity supports EOAs. So we have all of those things, and everything is kind of like compatible to EOAs. We have the MPC security layer. Everything that was developed around MPC wallets is now available if you have an EOA with MPC. And we have the usability features of smart contracts with the EIP 7702. So the great combination of those three things give us everything that we were looking for. But it's not just about the what, it's also about the how. And I want to focus a bit on the non-functional point of view. And I think the good way to look at what I'm talking about right now is if you're a CTO of a company and you need to choose how you want to operate, okay? Like you're an architect, you have 20 years of experience building systems. And like, what are the first things you think about when you want to adopt a new technology? So number one is backward compatibility. Like the first thing you're concerned about, especially if you already have a big business on chain, is what am I losing? Okay, like do I have new problems? Right? A lot of times we upgrade to a new technology, we get +1 on something, and then we get like -5 on other things. So first thing we care about as an architect is backwards compatibility, and 7702 is really good with backward compatibility. Doesn't break anything. If you already have like something built on your EOA, you have, I don't know, huge system using your EOA for a lot of operations. All of them continue to work. Nothing breaks after the delegation. That's really important. You can keep creating wallets. It's still free. The only time you pay for the 7702 delegation costs is when you want to delegate, when you want to upgrade. So creating wallets, still free. Creating transactions from the EOA, the cheap way, still possible. Signing messages with the EOA key, still possible. Using dApps that don't support smart contracts but do support EOAs, still possible. All of the SBTs you had, still on your wallet. All of the positions you had open in DeFi, still on your wallet. Nothing changed. And all of the reputation, the history of your account, right? Because a lot of time when we want to prove, for example, humanity, we might use our blockchain history. Still have that. So you lost nothing. You're fully backward compatible with everything you had. So that's like the first thing you look as an architect. The second thing you're looking for as an architect is future-proof. So, and again, this is like for any technology. It's not even for specifically for this, right? You want to make sure that any decision you make is not like horrible, right? Now, consider the situation that you run a big business on your wallet. You decide to upgrade to some new smart contract wallet. They convinced you they're good. You take them because they have the best features. And then they go out of business and they no longer develop the smart contract wallet. The question you will ask yourself is, can I move to a different smart contract wallet? And with EOA 7702, you can. It is very easy. You redelegate to a different contract. You undelegate the contract to revoke it entirely. You can make those changes. If you're doing a regular smart contract wallet, moving from one implementation to another implementation can be very complex. They're like, some are compatible, some are not compatible. There can be a lot of issues. There is no actual mechanism for doing this. I don't think there's actually a good tool to move from safe to mBuyer, or I don't know, like any other example. So this is important. This is a very big advantage and very big, again, something really important for you as an architect. And also remember, all of the new wallets that are being developed for smart contract wallets are for account abstraction wallets are pretty new. So it's actually important when you want to adopt a new technology, you want to make sure that you can revert the decision. So in a weird way, the ability to revoke increases the chance that you will adopt a new technology because the risk is smaller. You can always change your opinion. And another thing that it allows you is graduality of upgrade. So because you can redelegate, you can actually implement something small using 7702, and then implement something bigger using 7702. So it allows you, if you're a bit of more of a risk-averse technical leader, it allows you gradual adoption, which is something we like as tech decision makers. We like to have this control. Do I want to go full in, or do I want to go partially in? Those are important things. So there's no vendor locking, no implementation locking. Those are great things about 7702 wallets. Those were like the main things I wanted to cover on this. And like, you could ask yourself a question: is an EOA with 7702 still an EOA, or is it now a smart contract wallet? There's like the entire conversation about 7702. Is it account abstraction, execution abstraction, gas abstraction? Because there's a lot of layers to those things. A lot of those debates really belong in the people who try to build the protocols, right, and try to navigate. For the end user, it doesn't matter, right? For the end user, the only thing that matters as a result of this is what value do you get? What do you get outside of this? And I think this is one of the big things that like the CAP focused on, is just shortcutting some of the complex conversations about the future of Ethereum and talking about directly user value, which is the good thing and bad thing about it, right? Because like other like 4337 was much more directly aligned to native account abstraction, and 7702 is indirectly aligned into native account abstraction, and we'll actually talk about this. But I think the main value in EAP 7702 was user value as much as possible, as directly as possible, as simply as possible. Okay, so now I'll move from just talking about like the generic protocol itself into the product approach, right? Our product approach to some extent to EAP 7702. Because the question, obviously 7702 is a technology. And like I didn't mention this, but like again, I think, well, I did mention it somewhere, but like Fireblocks is obviously using MPC wallets and EOA MPC wallets as part of its infrastructure. So this entire conversation is very relevant for us. And the question becomes, how do you think about 7702? And there are a lot of different approaches, right? And not one of them is good. I want to present one of them, which basically said, we want to look at, basically like says, we want to look at the AP 7702 from the angle of our product. Not a general product, not a generic thing. What can you do with 7702? But what can you do with 7702 for us? And what became clear is that the easiest thing we can do is create some AA wallet. Doesn't take a lot of time. It's not very hard. And do some PR, right? Like that's the easiest thing we could do. Just publish, hey, Fireblocks has this open source EAP 7702 wallet. But we didn't want to do this. It doesn't give us enough to invest in. What we want is to integrate 7702 into our system progressively, so not necessarily all in. We want to introduce it safely because it's a new technology, and we want to focus on what is the most important thing for our clients, right? So it's like top priority, tangible value for Fireblocks clients. And again, I mentioned Fireblocks clients are very diverse. We have payments, we have tokenization, we have custody, we have retail platforms, we have treasury management, we have a lot of different use cases. So we really wanted to understand what people care the most about and deliver that. And over time, iterate, because this technology allows us to iterate. It is future-proof. Now, you can build a lot of things on EAP 7702. And this is a very partial list, but you can do gasless transactions. You can do batching of actions, so you can execute multiple actions at the same in one transaction. You can use session keys, so delegate control over the wallet temporarily to some other key that has different controls over it on the smart contract layer. You can do social recovery. I think actually the Ethereum Foundation with Kohaku right now is working on different like 7702 based social recovery features with a few participants there. And you can do on-chain policies for the smart contract-based signers, not for the EOA signer. You can do a lot of things, okay? And a lot of people are experimenting with those things. And we really didn't want to focus on just experimentation. We wanted to focus on a very specific value that we want to deliver. And we decided that the most important thing is gasless transactions. Now, what does gasless transaction means? It means you do not need Ethereum to send a transaction. Somebody else holds the Ethereum. He relays your transaction. Who is that something? There's a lot of different configuration. It can be 4337 paymasters, or it can be not 4337 relayers, which is the first thing we support. Now, why is gasless transaction so important? A few reasons. First of all, it's the #1 blocker for adoption. That's like at least our take. Because if the first thing you need to do to use a system is already be using the system, it's really bad. It doesn't work. And we've seen that. Onboarding into a blockchain wallet was very hard when you need to get gas tokens. So it literally targets the first step, the onboarding. Especially if we want to onboard in mass, right? We're talking about onboarding the billion users, then this is a problem that has to be solved. Will never happen without solving it. The other thing is regulation. So there's a lot of different regulations in the world. And in some places it's improving. Right now in the US, there's a lot of improvements. But there's a lot of jurisdictions in the world, and they have different take on can you hold Ethereum or not. And actually those things even change to the better and to the worse. And so we want to make sure we support all regulations. And this basically allows to support every regulation because you don't have to hold crypto to operate on chain. And obviously it applies to a lot of different clients, whether if you're a fintech, a wallet, like regulated institutions, unregulated institutions, a game, or like a bank. This applies to everybody. And mostly it applies to stablecoin, because stablecoins by definition are not native tokens. They're not Ethereum. So since we all see what's happening with stablecoins right now, every stablecoin movement needs somebody to pay for it on chain with Ethereum. So again, specifically for stablecoins, this is super critical, having gasless transactions. And 7702 is the best solution we ever had for gasless transactions. There were multiple solutions before, okay? A lot of people don't know these EAPs, right? Like there's a lot of different EAPs. You had like the Meta Transactions EAP, which came out of the gas station network, which was sort of a precursor to ERC 4337, which was good, but only worked if your token supported it. And you had the permit, right? EAP 2612, I think. And that was also good. You could permit actions, but it was like much more targeted towards the actual like only for authorizing a transaction of value, like transferring funds. It was not generic. It was not supporting all tokens and all use cases. Nothing was supporting all tokens and all use cases until EAP 7702 in this context, obviously without the trade-offs of 4337. And as I mentioned, you don't need a new wallet. So it's backward compatible. It basically touches on immediate availability across all of the use cases. All of the use cases, all of the wallet types, all of the tokens, you can get gasless transactions. So this is literally our first focus and launch for using EAP 7702. There's going to be more announcements around this, like but this is kind of like a target thing that we're working on and launching with our clients. We announced it already in Spark, in the Fireblocks user conference. So this is our adoption, and I think what is important to understand as kind of a last thing to touch upon before going into questions is 7702 is being adopted. Now it's a gradual process, but the great thing about 7702, the way it is actually inclusive of the 99.99 accounts that already exist on Ethereum, basically what we see is all of the big providers in the Ethereum space are supporting or starting to support or in the process of supporting EIP 7702. Few examples, obviously Fireblocks is working with this, MetaMask is working with this, Uniswap is working with this, Trust Wallet is working with this. So like, and again, there's a lot more. I don't want to neglect anybody, but there's basically across the ecosystem, not just the new entrants that came in for account abstractions, but actually the company that already have a mature business on the Ethereum blockchain. All of those companies are adopting 7702. And in the process, these companies are adding support for smart contract wallets, adding support for account abstraction features, adding support for gasless, will be adding support for things like batching and other things. And as they do this, as they support more and more of those account abstraction-oriented features, they're basically supporting more and more of the long-term roadmap of account abstraction, which will eventually end with native account abstraction. We all know that it is coming. We all know Ethereum will eventually transition to native account abstraction. And so I think 7702 is the perfect gateway into this ecosystem for the majority of the ecosystem on Ethereum. And so this is really a big advantage of this entire process happening in parallel with the 4337 process and in collaboration with the 4337 process, which is more targeting the specific nuances of how account abstraction will look when it's native. 7702 takes the more high-level approach of bringing people to the concept of account abstraction through a different adoption curve. And I do believe this is the inflection point in terms of account abstraction adoption in this ecosystem. And we'll see this in numbers over time. Again, since we're talking about the actual like bigger participants today, it is a process that takes a bit more time, but that wait is worthwhile for the long-term roadmap of Ethereum. And then we'll get like native account abstraction which will hopefully solve a lot of the things that we need to solve in the temporary implementation so that everybody can adopt it as the best option out of all worlds. That's it. That covers the things that I wanted to go over. Yeah, I'll pause for questions. There's a GitHub repository for 7702 content that we created. It's not the Fireblocks content, it's general content. People are still adding to it, so feel free to add if we're missing some great articles that explain 7702 better, or use cases on 7702, or systems that support 7702. So like, please feel free to open PRs. I try to review them pretty frequently. And people are still adding, so that's a good thing to see that it's a live thing, not just for the launch. And feel free to reach out if there's relevant things in this context as well. You have some contact information here.
All right, that was super interesting. Thank you very much, Arik. A few questions here. I see Lucas want to ask a question. So Lucas, one moment. I'll read out. Okay, so Lucas wrote, my question would be, to what extent Fireblocks itself is opening up 7702 set code to the developers? I know they use it internally for their gasless feature, but Arik may go on to it anyway, and well, it's still relevant.
Yeah, perfect. Yeah, so that's a good question. Okay, so opening set code as an open thing that you can do is a very risky thing. And so this is something that it's not that it will never happen in any way, but it will not happen in the simple way, okay? Like the simple way you could imagine is you go into Uniswap and Uniswap tells you, hey, here's a 7702 implementation, approve it so that I can give you whatever, batching. And that might be great if it's actually Uniswap and actually batching. But it's pretty much impossible for you to check that it is. And so there's a very big risk if we would allow this kind of a behavior that it will end with clients losing their money. And we like our clients keeping their money. Now, there's different approaches to how to handle this. I see you mentioned on like the MetaMask approach. MetaMask approach is more like they they have their own ERC for how they want to see people approving specific actions on their 7702 wallet. I think it's 7715 or 7710. I never remember between the two. So there are approaches for doing this. They're very new, very much evolving. So it will take time. It will take time until we feel that there is an approach that is mature enough, secure enough, gives the right properties. I can't promise it will ever happen in the simple way. There could be, again, like basically there's a very big product decision to be made here on how to enable more flexibility. But initially, we just want to give people more value and have them keep their money. So we do put security first here, and hopefully over time we'll be building more and more capabilities that allow users more and more freedom in how they use 7702. And by the way, this is a very common approach. Like a lot of the people that have introduced now 7702, first of all, we're not touching general approval because it's really still very hard to add security to it. And again, over time, we're going to be adding more and more things.
All right. Lucas wrote some follow-up questions. So to summarize, our client would look to set code to our smart contract.
Yeah, I think he's really going into a very, very specific thing. Again, we can take it into a separate conversation. But be very wary of something that allows very simple activation of this. And again, we can talk into more specific details about what can be done and how, and what the system allows, because Fireblocks is a pretty big system. There's a lot of different ways you can do things. But yeah, it's not. I don't think this is the relevant situation for 98% of people.
All right. So right now we'll let the participant think about some more questions. I'll ask some of them now. So firstly, any interesting or unique use case you've seen on Fireblocks infrastructure products?
Sorry, can you repeat that?
Is there any interesting or unique use case that you've seen using Fireblocks infrastructure products? Something that you've witnessed?
I don't think I can single out a single client and what they do, but so I will say that you've seen some of the stats at the beginning. In terms of how many clients we have that are building on Fireblocks. Some clients are very public about the fact they use Fireblocks, right? Because this is literally part of their security statement, and they want to make sure everybody knows they use Fireblocks because of the brand we have and the capabilities we bring. Some clients prefer not to mention. They don't want to talk about their tech stack. And so the reality is you probably used Fireblocks many times in your life without knowing. So sometimes it's not knowing because you just didn't read their webpage that says we secure our system with Fireblocks. And sometimes it's because they don't want to mention this, and it's totally legit. We don't want to enforce, we don't want to force anybody to disclose more than they want to. So it is very likely if you use blockchains directly, and if you use blockchains indirectly, right? Because you use some system and they do cross-border money transfers on the blockchain, it is very likely you interacted by Fireblocks, not just once, but many times by now. And again, I don't want to mention anybody specifically because, again, any use case that is built on the blockchain was built on Fireblocks by somebody. I would say probably without exception. But not every company, obviously.
All right. It's very cool. Thank you. Another question is you mentioned the work with more than 50 blockchains, as you said, or even more. You did mention specifically Bitcoin, Solana, these blockchains. I was wondering if there was a reason or just didn't mention.
Oh no, just did meant like obviously. Extensive work with Bitcoin, extensive work with Solana, extensive work with I don't want to start mentioning every blockchain that a lot of people use eventually is on Fireblocks. It takes time to bring in new blockchains because also those new blockchains need to prove value because there is a lot of competition between different blockchains. But again, all of the big blockchains are supported in Fireblocks, where a meaningful percentage of the volume that goes across all blockchains as general percentage of the volume that uses blockchain. Fireblocks is a meaningful percentage of that. So yeah, we're obviously in all of the big ones, and we collaborate. You can't collaborate with Bitcoin, but we collaborate with a lot of the foundations and the different not companies, right? Because that's not how our space is structured, but a lot of the teams behind all of the different blockchains, we work very closely with them to make sure that the systems continue improving across the entire spectrum.
All right, thank you. Leon has the question. Do you want to get on stage and ask it? One moment. All right,
hey,
Leon, you're on.
Arik, what's up? Yeah, very interesting talk. Thank you much for this. So I have just a question about on-chain policies. You said about the relations about EOA and the standards that can be delegated, but also there's some way to control the wallet itself. The EOA have some control. So let's say I want to delegate all the permissions to smart contract wallet. So all the on-chain policies is evaluated by the smart contract wallet. So is this possible with this standard?
Great question. And I'll go deeply into this because policies have a very interesting trade-off. So this is a core difference between EAP 7702 and ERC 4337, or generally the smart contract that is a natural smart contract versus an EOA with a delegation to a smart contract. In an EOA, the private key always has control. Okay, so you cannot take away control of the private key. The simple way of thinking about this is, I mentioned when talking about 7702, the private key can redelegate and undelegate, revoke delegation. So by definition, it has control, right? Now, I will say even more than this. Let's say you have a private key on Ethereum. And let's say you decided on the smart contract level to revoke that access, to not, if it was possible. It's not possible. But what happens on Polygon? What happens on Arbitrum? What happens on Optimism? If there is a private key behind the EOA account, you can never fully take out the control. By the way, what about a signed message, like a permit message by this EOA? Now, all of those considerations were part of the Ethereum core dev process for deciding how the CAP should look. And there was a lot of conversation about this because some people want the CAP to be a transition from EOA to smart contract. And other people basically, I think, explained that it cannot be a transition because the EOA still has power on other chains, even if you revoke it on this chain. So you really need to decide what you want, right? Like if you're starting from scratch, you need to decide what kind of security model you want. In an EOA account, even delegated EOA account, the private key has control by definition. Now, there's a system around us, right? So now, for example, this is now why this becomes interesting with policies. One of the problems with on-chain policies is that they also, even without the EOA mentioned, they only apply to one blockchain. So let's say you have a very strict policy on your Ethereum wallet. What happens on Optimism? You have the same, you can have the same wallet deployed to Optimism, right? But it will not have the same policy unless if you make sure it has the same policy. And then there's another blockchain, right? You put it on Arbitrum, you put it on Base. There's so many EVMs. Each one of them could have your wallet But now, let's say you have a policy and you have 3 signers, and you're very happy and you deployed it on 6 blockchains or 100 blockchains. And then you decided to remove one of the signers. So now you need to remove it on 100 blockchains. So actually having your policy tied to a private key might make sense operationally in some use cases. So there's a trade-off here. On-chain policy and off-chain policies have a big trade-off. Also, the fact your policy is on-chain means right now it's just visible to everybody. So everybody knows your policy. I don't think you know the policy of your bank account or your bank of the regular bank, right? So there's a lot of trade-offs regarding policies. There's obviously a lot of things people are trying to build to solve for those in a more decentralized way so that it is on-chain, but this is very much work in progress. And I will say also, the policies you see off-chain are much more robust, right? On-chain policies are very small, very simplistic. Because it's on-chain, it needs to be visible to the world. Off-chain policies can be a lot more complex. That's what we see in the real world, right? You can argue that it is Turing complete, but in reality, the policies on-chain are very small. The policies off-chain, 100 rules, arbitrary logic. There's a lot of different things that can go in there. So yeah, it's very much an architecture decision that people need to make. But to your point, in any way, doesn't matter what you do, private key has control. It does allow you interesting architectures because, for example, what you can do is you can put your EOA in a cold wallet, right? Where you're it's inaccessible, so that's how that is stored, right? Sort of very cold device, not wallet, cold device. And then you can delegate to smaller keys that have more access on chain, for example. So there's a lot of different architecture setups you can do. I think we're very early in the 7702 journey, and all of those architectures and best practices are still being defined. So there's no single way of doing things that is correct.
Yeah, great. Thank you much for the response. Yeah, it's very complex question, but yeah, I really like the standard. I remember there was a lot of just less notice. I remember when the standard was published about a year ago, there was really a lot of discussions in the group, the counter abstraction channels about pros and cons of the standard. That's probably you mentioned some of them. I remember Nethermind teams. Basically the client teams, I think they looked for more simpler standard, and the AA teams wanted to be a bridge to account abstraction, right?
Yeah. And I think to some extent 7702 there was, I didn't mention it because I don't want to confuse unnecessarily, but now we're in the QA. So there was a previous standard, 3074, which was different. And there was a lot of conversation about that one, and eventually 7702 was some kind of compromise between the needs of the different ecosystems that are part of Ethereum. That's part of the Ethereum process. So there was a lot of heated debates, a lot of Twitter threads, a lot of HackMD documents going around, and a lot of arguments. And eventually there's a standard. And now there's an entire ecosystem building on that standard. So, this standard does have in it, to the naked eye, it's just one standard. But in reality, it's a combination of standards that were possible to build that gave the trade-off that the most people could agree on. And like everything, trade-offs, there's actual trade-offs there. So for some situations, it's not as good as it could have been. But the trade-off is that for other situations, it's better than it could have been, right? So that's again, I think this is a healthy process, and we can always improve it. So if there are some things that we still want to introduce, we can always do another EIP to change this and evolve, which might happen.
Awesome, thanks much. I have some more questions. Maybe I just DM you them.
Yeah, perfect. Happy to. Okay. I'll let Eden moderate.
Yeah.
Yes, thank you very much, Leon. All right, we got some more questions. Firstly, Oren asked, isn't there an issue with TX origin equals MSG sender when delegating? There was some answers here, but I think he wants your comment on that.
Yeah, so I don't remember all of the details of this conversation. This was like a very again, meaningful part of like building up this this protocol. And I don't want to say something that is not 100% accurate. It was part of the conversation. There was some analysis by the Ethereum Foundation using like a third party for the impact of like this like sort of like incompatibility to some contracts. But definitely like you need to make sure this is like a bad practice for a long time now. So this is something that, like, generally speaking, should not be used. But yeah, I don't want to say something that's not fully accurate. So like maybe it's worthwhile following afterwards.
All right. Moving on. Are you at any chance planning to do anything similar to the MetaMask delegation toolkit, where they don't expose the authorization signature method for security reasons, but do allow TX batching?
So again, like I mentioned this, I think it's a very interesting paradigm that MetaMask is leading. It's a new paradigm. We haven't decided what we will do in the future about this. I'm not, like, again, I think there's a very strong team at MetaMask working on this. They're like innovating some new capabilities. We'll see where it goes. We're also, like, everybody in this ecosystem is talking, right? So there's a lot of different conversation about those things. But like, definitely an interesting thing to watch. And like, we'll choose our own path within this, as time progresses. But again, I do think we're taking like the gradual approach, and doing this kind of a delegation is kind of like maybe not last mile, but it is very like a very advanced use case on this technology. I think we'll see more paradigms. I will say, like, right now, I think this is the first paradigm that is introduced by a company that is not just the natural way of giving delegation to a full contract. I think we'll see a few more paradigms emerge before we actually merge into what is the best practice in the ecosystem.
Okay, following up the future, there's another question. Where do you move on from here? Like, what's the next step? What's the next phase?
So like, I don't think I should do our product announcements here. like there are more things. What I want to say is this is a very good technology for our use cases, right? Again, like everything is context driven. For us, this is a huge enabler. We will be doing more things with account abstraction, and yeah, that's it. Like, we have our ways of announcing features, so I'll stick to those.
For sure. Okay, about the proposal itself, what do you think would be like reasons or potential reasons to not approve the proposal?
Which proposal? I'm not sure I understand. You mean like the delegation?
Yeah, the EIP 7702.
Okay, so so I'll put the context. If we're talking about when you're presented, you have a wallet and you're presented with the option to sign in a delegation of your EOA. Not talking in the Fireblocks context. Again, I said before, what we support, we don't support. So it's not going to happen in Fireblocks. But in a general use case, if you're using a wallet that allows you to accept delegations just via UI, first of all, reconsider your options, right? This is very risky. Like, I'm not sure, like, again, I don't know of a wallet that does it today, like this simple way of just allowing you, because like you literally have to audit the contract you're approving. It is very easy to hide something in a contract in a way you will not notice. And as soon as you delegate, you lost control. That wallet, that contract can do whatever it wants. And if it wants to steal money, it will steal money. So generally speaking, you're not supposed to be signing those kind of messages. That's my take. And I know there's a lot of people in the ecosystem that agree. If you are in some use case in that situation, again, like, which I think will only come in as part of a system, right? A 7702 is not a user-facing feature to some extent. It's an infrastructure feature for people that are either an app or a wallet that you use. So in those cases, they will likely show you only ability to sign delegation to contracts that are part of the system. If it's a wallet, then it's a part of the wallet. If it's a app that controls your wallet, right? Not an app talks to an external wallet, maybe an app that created an embedded wallet for you. They might ask you to upgrade that embedded wallet. But it will come in the context of that feature, because honestly, like, I don't know how you even like, what are you going to do? You're going to go and start reading the code on Etherscan to understand if this is good code. And like, that's even if the code is there, right? Because you don't have to share code for a smart contract. So like, again, this entire use case of approving this is not built. So what you will likely see is some app saying, like maybe a wallet saying, hey, like I think MetaMask does it today, right? MetaMask kind of tells you, hey, you want to use gasless here, or you want to use batching here, approve our smart contract for 7702 delegation. And then you have to decide, do you trust MetaMask? Because it's their wallet, it's their contract. You basically need to decide how much you trust them to use their wallet, to use their smart contract. Yeah, so it's much more of a trust decision than a technical decision. Because again, unless you're one of those 100 people in the world, you shouldn't be starting to evaluate 7702 contracts based on their code. Yeah, that's my take on it. And this is different in the MetaMask situation where they tell, do you want to allow digitalization inside 7702, which is a different thing. But again, this goes into like an entire different paradigm.
All right. Thank you. Moving on. Does this idea exist in different blockchains already today?
Great. So indirectly, right? So different blockchains have different take on accounts. And some blockchains, for example, have native account abstraction sort of by definition to the way they work. Either because they're an EVM chain that activated account abstraction. Starknet has native account abstraction as a must. ZK Sync has optional native account abstraction. So like they're different in that sense. So they have some of those concepts, but it's not like 7702. And other blockchains have like a different kind of account abstraction. Again, we could start comparing like the Solana model, but I don't think like it makes sense to go into this like in this context because it's very different. So I would say 7702 is an EVM specific solution to an EVM problem and an EVM direction of evolvement towards account abstraction. It's not the same as anything else. And again, obviously, I'm talking about EVMs, right? Within EVMs, a lot of the other EVMs adopted 7702 pretty quickly. There's a few that haven't yet, but most of them already did. Some of them literally on the day of the Pectra fork. So you can probably assume any EVM will likely have 7702. Again, with a few notable exceptions.
All right. Okay, moving on. So Fireblocks has different patterns on MPC. Do they have any advantage on 7702?
I'm not sure how to answer this. Like, listen, like I think there's different, like, I don't want to turn this into a Fireblocks sales pitch, but I'll say that, like, you know, Fireblocks is Fireblocks. We do things a specific way. From our experience, we have experience with a lot of companies, with a lot of clients. We have a lot of input from our clients, what they're looking for, why they use us, what they want from us, you know, a lot of those things. So a lot of what we do is a combination of the tech decisions we believe are right and the things our client ask for and need from us. So obviously our approach is like Fireblocks specific. Again, here, for example, we decided on an like within 7702 decisions, we decided on an approach that builds in a lot of security into the smart contract, and does not allow all of the things you can do with 7702. So we took a very deliberate approach towards the feature we want to support with the maximum amount of security, with the context of this is part of the Fireblocks service. So it's not something you can just use by yourself in 7702 generally. It's like very tied to our offering. I think it's the right approach to do things. That's why we're doing it like it, you know? But it's, you know, that's like, because we do take like a very security-oriented approach towards this, which means gradual adoption, security first, a lot of additional security capabilities that we don't talk about all the time. That's kind of our approach.
Okay, so it sounds good. So I don't see we have any further questions. So okay, so let's move on to one last question. Actually, I have like a kind of off topic, I guess. So if someone wants to start building using the EAP 7702, you know, everything we just mentioned, talked about. Do you have any worth mentioning mistakes someone should like try to avoid when using that when using it?
Yes. Okay. So again, I mentioned a few, but I just want to re-emphasize. 7702 is backward compatible to EOAs. It is not backward compatible to other smart contracts. Never delegate to a smart contract that is not like, or if you're trying to build a system, like, you know, again, a simple mistake you might do is take a smart contract you like that is not 7702 compatible and use it in 7702. That would be horrible. So don't do that. Only take a smart contract or build your own. But if you're not building your own, take one that is 7702 compatible, which means it avoids a few specific ways of doing things wrong. For example, in the initialization of the contract, which is like the biggest thing, that there's basically like you can create an attack where you can create a situation where somebody can attack you, and when you delegate to the contract after initiating, they take over the contract. So so make sure, I think actually some of these are mentioned on the EAP itself as security concerns that people need to account for. But if not, read some material. And if you're not at the level that you want to build your own contract, take something off the shelf. There's a few companies that offer 7702 implementations that you can start off. You can use the MetaMask version, which has 7702 built in and is open and public. You can use Alchemy has a 7702 version. I don't want to like, I think Economy and Rhinestone and like, so I don't want to forget anybody, right? So there's like a lot of companies that have wallets and or 7702 contracts in the space. Take something that people built purposely for 7702. And the second thing is, don't be, again, be very wary of 7702 delegations that are not coming from the code that you're very familiar with. Generally speaking, I think you should not allow arbitrary delegation by apps. I think most of the people in the ecosystem agree, not everybody. Some people think you should. But if you do, this should be a very, very, very specific decision. My recommendation, only delegate to contracts you understand, maybe only contracts you wrote. But again, new paradigms can be created here, but like this is very important just because like this opens you up for an amount of attacks that is unimaginable. Yeah, there's a lot of material. Go into the GitHub that I shared earlier. Awesome. You don't have to remember the link. Just look up awesome EAP 7702. There's material there from all of the companies I mentioned and more. So like it's not, again, not anything specific to us. It's just curated list of articles from people in the space that understand this protocol. So like it's worth reading that, learning from them before you build anything.
For sure.
And
Great.
some
Thank you
really
very
great
much.
questions. Really appreciate all of the questions. Like went really deep. I hope it was helpful for everybody.
I'm sure it was. To sum it up, Arik, thank you so much. Really was a special session, and thank you to all the participants who joined us today. And for you guys, please help us grow and follow us on X, on social media, um, and see you at our next meetup at October 15th. We're going to host Consensus. All the details will be available through our website on web3devs.org, or also on our Luma or Meetup calendars. And also, if you want to take an active part in our community or speak at our next event, please let us know and reach out through Telegram or on our website. And for those of you listening to us for the first time, we're Web3 Devs Underground. We're all about top technical content, open source, no shilling, and all done by devs for devs. So everything we do is always free, reliable, and for the community. We thank you all for joining us today, and we hope to see you next time.
Thank you very much.